look at a number line model for a particular graph. Let's take y equals, or f of x equals, whatever you want to say, 2 minus x times x plus 5 times x plus 3. Now we're going to make a number line model, and then we're going to talk about a couple of other things about this graph. So, our number line model, we need to know our x-intercepts. Well, our x-intercepts, 2 minus 2, then this would have to be a negative 5. The only way this parentheses would be 0 is if x is 0. And then the value that makes the last parentheses 0 would be negative 3. We must place them in order. So I have negative 5, negative 3, 0, and 2. First interval is negative infinity to negative 5, negative 5 to negative 3, negative 3 to 0, 0 to 2, and 2 to infinity. In each interval, I'm going to choose a point to plug in to test my signs. So in the first interval, if I chose, let's say, negative 10, 2 minus a negative 10 is going to be positive. Negative 10 plus 5 is negative. Well, that's just negative 10. It's definitely negative. Then negative 10 plus 3 is going to be negative. Positive times a negative times a negative times a negative. Remember, if you have an even number of negatives, you're going to have a positive answer, but an odd number of negatives is going to give you a negative result. Something between negative 5 and negative 3. Well, negative 4 sounds good. 2 minus a negative 4 is positive. Negative 4 plus 5 is positive. That's negative. Negative 4 plus 3 is negative. 2 negatives means my result is going to be a plus. Between negative 3 and 0, darn it, I can't pick 0. How about negative 1? 2 minus a negative 1, positive. Negative 1 plus 5, positive. Negative 1 is negative. Negative 1 plus 3 is positive. I have one negative, so my result is going to be negative. Between 0 and 2, let's go with 1. 2 minus 1, positive. 1 plus 5, positive. 1, positive. 1 plus 3, positive. 4 positives in a row. My result is going to be a positive. Path 2 to infinity. How about 5? 2 minus 5, negative. 5 plus 5, positive. 5, positive. 5 plus 3, positive. I only have one negative in the answer, so this is going to be a negative result. So this graph starts off in the negative world, starts off down here, goes up, goes down, goes up, and goes back down. Now it keeps going back down. If it turned around, we'd have another x-intercept. But since we don't, we know it just keeps going and going and going. Now, we're going to talk about something about how we could use this graph to solve inequalities. Solve the inequality. When you're solving an inequality using a graph, you're looking at either the intervals that make you negative or the intervals that make you positive, depending on what the problem asks for. So let's say the problem said to solve 2 minus x times x plus 5 times x plus 3, and we want to know the values that make that less than 0. Now, less than 0 means I'm talking about my negatives. So I'm going to look up to the graph and find all of my negative pieces. Now, it says negative, but it doesn't say it includes 0. If it had said it includes 0, we would actually include our x-intercepts. Not including 0 would just mean we're looking for the intervals that give me a negative answer. Well, this one gives me a negative answer. This one gives me a negative answer. And that one gives me a negative answer. And I'm going to connect them with U's. That means we're unioning those three pieces. Now I'm going to change the problem. What if it had said that we wanted to know when this function was less than or equal to? Now it's the same intervals because we're talking about less than, but because it says less than or equal to, we're going to include those endpoints. So we're changing those endpoints to brackets. Now, what if I changed it from negative to making it, what are the solutions that make everything greater than or equal to 0? Well, greater than 0, we're talking about positive, or equal to means I'm including the endpoints. So that would change it to -5 to -3, bracket, and then 0 to 2. Now, the last piece that we can answer using this is what is called end behavior. You talk about what is happening at the ends of your graph. So what we're looking at is what happens as x gets really, really big or really, really small. If we look at what happens as x goes to positive infinity, when we start plugging in bigger and bigger values, we plugged in a 10. What if we plugged in 100? What if we plugged in 1,000? What kind of answer would we get back out? Well, everything from 2 to infinity, doesn't matter what I plug in, I'm going to get a negative number. Now, the bigger the x value I plug in, the more and more and more negative it's going to go. So what we say is that as x approaches positive infinity, as we plug in bigger and bigger x values, f of x is just going to keep getting smaller and smaller and smaller and smaller. It's going to go all the way down to negative infinity. It's going to keep going down and down and down and down forever. Now, this is the right side. If I look at the left side, when x gets smaller and smaller and smaller, so if I plug in -1 million and -2 million and -3 million, well, I'm still going to get a negative answer out, right? It's just going to keep going down and down and down and down and down. So we say that f of x approaches negative infinity. If it had gone up instead, we would actually change that to be a positive infinity. So let's look at some other circumstances. What if I had been given a graph it was something like that? We would say, as x goes to positive infinity, as we look to the right, it's going up and up and up and up and up and up. So f of x keeps going up and up and up and up and up until it goes to positive infinity. If we look at the left side, as x gets smaller and smaller and smaller, smaller and smaller and smaller and smaller, the graph is going down and down and down and down. So as x goes to negative infinity, f of x goes to negative infinity as well. What's nice is we had talked about even and odds. Evens are going to have very similar behavior to each other, and all odd functions are going to have the same type of behavior. This would be the type of behavior of an odd function. An even, a normal even, would look kind of like a quadratic. It would do something like that, which would mean that as x goes to positive infinity, f of x also goes to positive infinity. Because it doesn't matter what kind of value I plug in, I'm going to get a positive answer out. Whoops. If we looked at what happened when x gets really, really, really negative, like -100, well, if I plug that into x squared, it's going to make it positive as well. So it's always going to go positive. Now, the only time those change is if you have that negative leading coefficient. If the leading coefficient is negative, it's going to flip it. They're going to literally flip over. The graph flips. I can't spell flips. So if we had an odd and it flipped it, it would start up and go down. An even that's flipped is going to be upside down. Now the main thing you're going to have to learn in this part is actually that notation for the end behavior. Remember, when you're looking at what happens as x gets big, you're looking at the right side of your graph. If you're looking at what happens as x goes to negative infinity, you're looking at the left side of your graph.